So today we're going to talk about exemplars, and we're going to do kind of a walk through what they are, why they matter, and maybe some information about the future of them. My name's Joel Groen. I'm a product manager at Chronosphere. If you don't know Chronosphere, we are an observability company that solves problems at internet scale. So especially around if you're having problems at scale and managing the data at scale, a lot of people come to us for that reason. So, and we're here today and tomorrow. So if you want to come down and visit us, I'm happy to give you some more details then. So today, during this session, we're going to talk a little bit about exemplars. And you would think that if the subject is exemplars, I would just dive right in and describe what an exemplar is right out of the gate. Not going to do that. I promise we'll get to that, but I'm going to set a little context first so you understand what they are, why they came to be, and then how they're used in today's observability world. So to jump right in, let's just go to the life before exemplars. Not that long ago. Exemplars are pretty new. But you're on call, it's after midnight, and you get paged, and the application your team is responsible for has an authentication service that's generating spiking in errors, and you need to figure out what it is. So I assume that's not an unfamiliar scenario to all of you. So you get the page, you jump out of bed, and you're hoping that it's something that you can just downtime and go back to bed, but it's something that looks like it might be a real issue, so you need to dig in, and that usually means heading to dashboards. So you're looking around your dashboards, trying to find some indication of what might be going on inside of the system, and you root around and you make some hypotheses and you start guessing, a lot of it based on your previous knowledge and just kind of how you understand the nature of your system. But you can't really get to any kind of conclusion, so then you jump into traces. And the problem here is, before exemplars, is you're not bringing any context with you. You pop open, this is Jaeger, but it could be Zipkin, it could be any other tracing application, and you just start looking, and you start writing queries, and you don't really know how to tie what you were seeing on the dashboard to what you're trying to find in your tracing data. So that's frustrating. It's not very productive. Hopefully, in some reasonable amount of time, you've been able to resolve whatever you need to resolve, and you get back to bed, or at least hold off until the morning when you can really dig in deeper. So if that scenario I just described is reflected in this room, my apologies. It's not a great way to be on call. I'm sure you have the sympathy of everybody else in this room, but it's the reality for lots of systems that don't have that ability to take the context of one system and bring it back and forth to another system. So then we moved towards integrations, and there are a lot of systems out there now that are providing integrations based on having two or more of those signals joined together. So you might have metrics and traces, you might have logs and traces, you might have metrics and logs, whatever the combination is. Some of them have all three. And the idea there is, if the systems are together, then making that jump, that contextual jump from one to the other, gets a lot easier. Here's a simple example of Prometheus and Loki, and in a perfect world, you find a relevant trace ID inside of your logs, and you can jump straight in and look at that trace, and it helps solve your problem. There's a lot of issues with that, though, and it assumes that you're not sampling, for example, and that the trace that you actually bring over from your log is actually there. And then on the metric side, it's even a little bit more complex. So a lot of what's happening is you're trying to take two data sets, one, all of the traces that your system is producing, and another one which is all of the metrics your system is producing, and find some connective tissue. And so oftentimes you'll see that done using time, so a time window, and then hopefully your system has the data is in great shape, and you can find some label or tag and find a way to cross-reference them. And so if you see this in one system and you can see a correlating label in the other and you have a timestamp, you've got something to go on then and you can jump across. And so that's what a lot of people are trying to do now with those data sets. But that also comes with challenges. So if you're looking at your dashboard and you're looking at errors, if we go back to our previous example, and that's a roll-up, an aggregation of a bunch of errors across a bunch of Kubernetes clusters, a lot of that metadata that you use to make that connective tissue gets wiped away in the process of aggregating. And as we talked about, if you don't have all of the data, if your system cannot scale and store 100% of your traces, there is a real chance that the trace you're actually looking for wasn't sampled and isn't in your system anymore. So we talked about the 1 in 10,000 problem. So especially when you're looking for latency issues, there are lots of companies that sample because of sheer scale only 1% of their traces. In fact, I know of a company that samples 1/10 of 1% of their traces. So if we use the 1% rule, and you're only keeping 1% of your traces, and you're looking for a P99 issue, you've got a 1 in 10,000 chance that the trace that you're going to pull will actually be representative of the problem that you're trying to solve. So even with these integrations, we still haven't gotten to the point where we feel confident that as we're doing our investigations, we're finding the trace that we need that's going to help us unlock what the root cause of this issue is. So now we can jump into exemplars. So that is an effort to try and make a more methodical, programmatic connection between your traces and your metrics. So typically what happens is within your metric data, you can now append or connect some other piece of information. Typically that is a trace ID. And what you can see here on the graph on the right is those little diamond shapes. I don't know how they look on the screen. I assume you can see them, the little dots there. Those represent exemplars that are attached to the sample of metrics that are coming in, the metrics being the underlying green graph that you can see. And so now we've got a way that we can feel confident that the graph that we're looking at that is showing us that something is wrong, we have a way to actually dig in and make that leap over to do further investigation using trace data. So exemplars work great in lots of scenarios, especially when your data is fairly homogeneous. You want to know that the problem that you're solving, a lot of your traces are going to look the same. The problem is not overly complex. There's not a lot of variables. And that way you have a much higher chance that the single exemplar that was identified as relevant to that point on the graph is actually going to be representative and help you solve the problem that you're looking to solve. It's a great way to help you jump back and forth. So you get to bring context with you. So in example 1, where you just had to just open up Jaeger and start searching around, now you have a way to connect those two sessions together, if you will, and to find better ways for you to manage that investigation. And then the other good thing about exemplars is that they are getting a lot of support in the OSS community right now. OpenTelemetry is spending a lot of energy on them, and I think Prometheus, the 2.27 release, which is now almost a year and a half old, had an experimental, included some experimental code for exemplars. So you could actually go in as a developer and tag trace ID or whatever other piece of information you wanted inside of your Prometheus requests. And so it does have that support. That's a great thing going forward for exemplars, that the open source community is supporting them. So now let's run through the scenario again. It's still a little bit after midnight. You still get paged. But now when you go to your dashboard and you're looking at errors in your authentication service, you're trying to figure out what's going on, and now you've got exemplars to help you. So instead of just opening up Jaeger, now you're just leaping over to whatever your tracing application is, and off you go. And in this particular case, we'll take the spike in errors, and we'll use the exemplar that you can see there circled. And off we go over to Jaeger with what we hope, because it's an example of what it's an example of a trace that is associated with that point. We hope it's got the information that we need. And that's kind of where exemplars end today. The problem is, and where we need to go further with exemplars is, I still have a bunch of questions. I don't know, because it was the authentication service for my Android app that was airing out at in the middle of the night. I don't know if it's an Android-only problem or an iOS problem. I'm only looking at one trace, and I know that that one trace is only going to show me one of those two operating systems. I don't know if it's all of my Android versions or if it's just a single Android version. So again, a single trace doesn't give me the context to answer these types of questions. Is it across all of my application deployment, or is it limited to a specific geo, or is it a certain region inside of AWS where all of this problem is occurring? I need more context, and the challenge, the reason we need to go beyond exemplars is because that one single trace isn't enough data and isn't enough context to help me figure out if I have the error that I need to be searching for, or if I need to keep digging and really get to root cause. So, as we just talked about, they're great for homogeneous types of situations where you have a fairly high confidence that all of the traces look alike and that your error is likely to be found inside. And we also have the secondary problems. We talked about that through OSS, a developer can now make that tie, but now you're asking a developer who's writing, who's instrumenting metrics to make decisions in advance of a problem about the trace that should be associated with that problem once it happens. And so there's a high probability that your developer is not going to have the full context. Maybe they'll get it right. Maybe they know the shape of the data really, really well, and they'll nail it, and that exemplar will be right on the nose. A real chance that that exemplar that they've chosen to attach to that data point isn't going to be relevant enough to help you solve root cause and get to the bottom of what the issue is. So that's why we get to kind of looking for the needle in the haystack. So you've got an example. Is it the right one? Does it have all the context? Can it help you answer the question that you really need to know? The answer is probably not. So what do? Let's talk about going beyond exemplars. So the first thing that we want to do is we want to have a system that doesn't force me to have to sample down my data. I want all of my traces whenever possible. Now, that is not feasible for all organizations for a variety of reasons, but you want to make sure that the system that you're using at least allows you to have that flexibility so that when you're pulling up a trace, you don't run into this 1 in 10,000 problem, that you have a realistic belief that the trace you're looking for is there because because you were able to sample it. And then you also want to be able to look and have the flexibility to go across the entire population of traces. So we want to talk about looking at a set of traces instead of one trace and using that to help drive the investigation. So rather than being handed a trace that was predetermined by a developer weeks or months or years before, I want to look at the traces that are relevant based on that particular moment in time on my dashboard. And then I want to use that to get the context that I need to really get to the bottom of it. So let's walk through what that might look like in terms of a demo. I'm just going to refresh this real quick. So this is the dashboard. I got up in the middle of the night, and I can see that there are some errors here. And in the same way that exemplars work, the power of this is I can click into this, and it can take me to traces that I know are relevant. So now I'm looking at a bunch of traces, but instead of a trace, what I'm looking at is a statistical analysis of all of the traces that occurred given this span filter that I added by clicking on that point in the graph and the timestamp in and around that timestamp. I'm now looking at a set of traces, the more the better, and I'm looking at a statistical analysis of all of these traces. So that error was on this demo music front end service, and I can see that play track is the operation that was airing out. So I've already added that to my span filter, and now I'm looking at a whole set of traces that have that characteristic, and I'm able to make some conclusions about that. Obviously, I can see that that error percentage is 100 for that particular thing. It might be interesting to me to find out that this elastic FE track is also airing out at 100%, so I might want to investigate there. I might care about some other information here. I can also go look at the metadata that came along with that. So this is an analysis of all of the metadata of all of the traces that were in that sample set that I created by a simple click on my Grafana dashboard. And I can see some things that might be interesting here. I can see that I know that I care about production because it's the middle of the night, and if it's in a staging system or some other system, I just don't care. So I'm going to add that to my trace, or excuse me, to my filter, and then rerun this and see what kind of information I get. So now I'm starting at the top, and I'm starting to narrow down my search based on the factors that I know. And the interesting thing for me is, let's just say I care about error percentage because that's what I'm searching for. And it's interesting to me that this Geo Japan, 73% of all of the traces that are in my sample block coming from the Japan region are airing. So that's an area that I want to investigate further. So with a simple click, I add that to my span filter. So now, again, the funnel is getting smaller. I'm starting to bring down that scope of what I need to understand to find the right trace. I may find that this is the spot I feel confident that I now have traces. I can now scroll down and look at the most relevant traces based on the filters that I just added. I can see that they're all resulting in errors because that's what I'm trying to solve for. And maybe I care about the ones that are taking the most amount of time. So I'm going to start my investigation by clicking into this one and starting to dig in. So now, instead of just having a single trace based on an exemplar, I've been able to start with the same idea of linking that data from my metrics into my traces and use the aggregation of the data in and around that time with as much of sampling as I can to narrow down to what I have a high confidence in. I'm now looking at a trace that has a relevant amount of information to the problem that I'm trying to solve. And I can see the critical path in here, and I can see a bunch of things, and we won't spend a bunch of time going into that, but where we want to go with tracing is the ability to not just hope that we magically pick the right one, but to bring in a group of them, do some statistical analysis of them, and use that to filter down to the place that we want to go. So, with that, I will let you know that we are in booth 215 for Chronosphere. Come on by. We're giving away an Oculus Quest 2 headset, so you can come by and have a chance to win that. A lot of smart, fun people down in the booth ready to engage and answer any questions you might have. And with that,